So we talked earlier about a rational number could be a terminating decimal or a repeating decimal. So they give us some numbers here and they want us to write each one as either a terminating or repeating decimal. Now it's going to be one or the other, either it terminates or it repeats. And the way we do that, so on A here, we divide the bottom into the top is what I usually say. So I'm going to take 7 and divide it into 5. And I make that 5.0. And then I'm going to use as many zeros as I need to either get it to repeat or to divide evenly to stop. Okay, so I'm going to do this with long division, just it may have been a while since you've seen math and long division, and I just thought it'd be fun. But in all actuality, I probably would just get a calculator. Okay, 7 does not go into 5, not big enough. So now 7 into 50 goes 7 times. 7 times 7 is 49. So long division. So we have a remainder, so we're not done. 7 goes into 10 once. This is going to take all my room. 1 times 7 is 7. Subtract. Add a 0 because I'm not done. It didn't stop. 7 goes into 34 times. 4 times 7 is 28. Subtract. And you might say, well, when is she going to stop? Well, I have to keep going until I get, when I subtract, I get a remainder that's the same as one I had before. And I haven't gotten one yet. 7 into 20, 2 times. 2 times 7 is 14. 6. Usually at this point we're like, well, couldn't we just stop and round it off? We don't round off unless they tell us to. 7 goes into 60. How many times? 8. 8 times 7, 56. Remainder 4. We gotta be getting close, right? Sometimes they'll say accurate to 4 decimal places or something like that. Okay, so 7 into 40 is gonna go 4 times. That's 28. Oh, no, I'm wrong. 5 times. Yeah, maybe I wrote this one down wrong. 35. Okay, good news. That 5 right there is the best news we have on this problem. So remember when we started out with a 5 right there? So now if I add a 0, I'm getting 50. I'm back to that 49 and it's all going to start repeating again. So this is the part that's repeating. It's called the repetend. I think that's what it's called, if I remember right. So to write that as a repeating decimal, it's 0.714285, and that part's repeating. Okay, but wait, I mean, that was kind of a long one to do by hand. It was negative, if you remember way back, it was negative, so I'd say don't forget the negative sign. So you want to write your answer as -0. You want that 0 there, I'll explain in a minute. And it was 7, what was it? 7, 1, 4, 2, 8, and then it repeated after, oh, and a 5. And that part's repeating. Okay, so you'd want to write your answer like something like that. We want to put a 0 before the decimals. For those of you going into the nursery program, they're really big on that because it just helps clarify where that decimal is, and it makes a big difference where the decimal is, right? Okay. Now that was the hard one. B, not so bad. 15 over 5. Well, 5 goes into 15 3 times. I can just write it as a 3. I don't have to put 0.00. It just is an integer, and that's considered decimal notation. Even though we don't see the decimal, we know the decimal's to the right of the 3. Okay, that one's done. 25 into 13. So we'll do the same thing. We'll set up a long division here, 0.0. Think of 25 going into, what, 130? It's going to be 5 times. 5 times that's 125. And then I subtract. Oh, good. 25 goes into 50 twice. Okay, that one wasn't so bad. So 0.52. That's a repeating decimal. It was not negative, so we will just leave it like that. So our first one was a repeating decimal. It went on for a while before we got that to repeat. The next one was actually an integer, but that's decimal notation. It just is a 3. And our last one was a terminating decimal 0.52.